All right, let's do a little bit more work with this, but this time we're going to use a slightly different form of substitution. So we're going to call this Solving Systems via Substitution Part 2. All right, so if I'm looking at Part 2, let's say I have an equation like this. All right, in this equation, I have them in standard form. Notice in the previous examples that we did, we had them in slope-intercept form. So if you have it in this, it's extra work to move it into slope-intercept form, so we're going to keep it right here in standard. So if I want to use substitution, when I have ax plus by equals c, here's a really easy way to do it. What we're going to do is simply solve one of them for y. So which one do I want to end up solving for y? Well, I could do this one, but I've got a coefficient in front of my y, so this one's going to require a little bit more work. If I come down here and I solve this one for y, all I have to do is move my x over here. Okay, I'm going to choose my second equation because I have just this coefficient of 1, so it's going to be really easy. So let's move my 6x over to this side of my equation, and what I'm left with is y equals negative 7 plus 6x. Okay, this is pretty easy to work with. The second step that I want to do when I have equations in standard form is to write an equation containing only one variable and solve. Or in other words, I'm going to end up taking this equation right here, and I'm going to plug it in for y in my second equation. And this is y equals. So I'm going to take this guy, and I'm going to come up to this equation, and it's going to go right here where I have a y. It looks something like this. Notice I took this equation up here, equation number 1, rewrote it, and all I did was plug my y value right here, it's equal to y, and plugged it in right here where y is in my original equation. So now everything is in terms of x's. Look at this, I have to distribute this over here, so watch out. But I'm going to get this 3 times negative 7, bring down my sign, remember this is distributive, and you've got to take your 3 to your 6. 3 times 6x plus 2x equals 4. All right, now I can end up solving this, and 3 times negative 7 is negative 21, plus 3 times 6x, which is 18x, plus 2x, and all of that equals 4. Now what is my next step? Can I move anything? No, I need to combine my like terms. I have similar terms right here. So I need to get these equal to each other. So I'm just going to bring negative 21 down, and 18 plus 2x is 20x equals 4. All right, all of my like terms are combined. Now I can move stuff. So let's move our 21 over here with my other. I've got 20x. Make sure you watch your sign. It's positive. We're good. That equals 25. Solve for x and divide by 20 on both sides. What does x equal? Well, hopefully you were able to figure out that reducing and that x equals 5/4. So I'm going to come back up here, and remember that when we solve and check, we want to solve and get something in here. So if I know that my x equals 5/4, that is my x value. That goes here in my ordered pair. All right, so at this value is where this line intersects with this line. All right, now we have to find our y. So let's come back over here where I already have my y equals equation, and we are going to plug our x in here. So it's going to look something like this. I took this equation, and I plugged my x value up here in for my x value, and this is what I get. So now I can simply solve for y, and y is going to be negative 7 plus 6 times 5 over 4. Or, all right, this is pretty icky, so you got to remember how to deal with fractions. So in order to add whole numbers to fractions, you have to get everything in common denominator. So 7 equals how many fourths? Well, remember this is 7, 1. What do I have to do to 1 to get over to 4? Well, multiply by 4. So what do I need to do to my 7? Multiply by 4. So this is going to give me 28 fourths. So let's plug that back in here. 28 fourths plus 11 fourths. And now I can solve pretty easily because I just simply add across. And negative 28 plus 11 is what? Good, negative 17. So negative 17 fourths is my y-intercept. All right, and if you want to make this prettier and make sure that you have actual numbers to plot, this is 1 1/4. Girls, please be working on lab, and this is negative 4 1/4. Okay, now in order to check this, I would need to plug my x value here in to one of these equations up here and solve for y and see if my y equals negative 4 1/4. Okay, I'd like you now to do this process. Remember, our process was 1, we're solving one equation for y. We're plugging that equation in for y in our second equation. And then we are finding our x and plugging our x, plug x in one of the other equations for y. Okay, last step is to check. I'd like you on your own paper to please solve this system using substitution. All right, make sure to show your work, check yourself, and remember this in class.